You have heat and AC, but the blower isn't blowing any air. It either doesn't work at all, doesn't have all the speeds, or only has high speed. Let's take a look at why and how to fix it.
We've got an 02 Dodge minivan, and the complaint is that the blower isn't working right. The symptom is it blows on high, but it won't blow on any other speed. It's a very common problem on these. If you're a do-it-yourselfer and you'd like to fix it yourself, you can do it. We'll show you how to do it. To verify this, turn the key on. The key has to be on, and at your blower motor switch, if you notice, there's no blower at low, medium high, but when you go to high, you can hear the blower running. So if you have a blower on high only, the blower resistor is bad. We'll show you where it's at, how to change it, and how to test it.
A question for you. How do we know that the switch is good and the blower resistor is bad? Well, the answer is in the electrical diagram. The electrical engineers design the vehicle to work correctly, and they give us electrical diagrams. All that's to show us how it is supposed to work. So if it is not working correctly, well, the answer can be found by understanding the diagram. So let's take a look.
Your blower resistor is located behind the glove box, so take the glove box out, take anything that's in it out, and then there's two little tabs you just push in right here, which will make your glove box fall down. Your blower resistor is located right here.
On many of the newest vehicles, the blower speeds are controlled by the BCM, the body control module. But on many vehicles, the speeds are controlled by what is called a blower resistor. And they can look like this. They can vary by year and manufacturer, but they all work basically the same way. Because of that similarity, let's take a look at one specific type. Here's a 2002 Dodge minivan. Let's use that for our focus. Now remember, they all work basically the same.
Now spend a minute studying your diagram. Power always comes from the battery. In the diagram, you'll see that it now goes over to this integrated power module, and inside that power module is the front blower motor relay. Now when you turn the key on, power comes over from the battery to this blower motor relay, and it just sits there waiting to be activated, to be turned on. Once it is turned on, you'll see that the path continues down through a 10 amp fuse inside the power module. Now I'll enlarge the diagram so you can see the completed path. The path of the power now goes from that fuse down through the blower resistor all the way down to the motor. Once it gets to the motor, it sits there, it's looking for ground. So now we need to see where is it going to get its ground. It's going to get it from the heater control module. Inside the heater control module is the blower switch that gets a direct ground feed from a ground connection. To test this with your test light, you should have power as it leaves the module, power as it enters the blower resistor, power as it exits the blower resistor, and power at the beginning of the motor. You should have ground at the input into the blower switch. Now this is your system at rest. The blower switch is a dial switch that has off, low, 3 mediums, and high. Now, in our case, we had high but no other speeds, so let's verify that first. So we turn the switch and give power to number 5, the high side, and it goes around, and the motor runs. It's got power and ground, so it runs. Let's test another position. Position number 4. Turn the switch to number 4. Ground makes it that far, but the motor doesn't run. Why doesn't it run? You've got ground in it, but the ground is not making it to the motor because you've got a break in the circuit in the resistor. Let's try another position. Position number 2. You turn the switch there, you have ground, but the blower motor doesn't run. Remember, you've got the same break in the circuit. You can use your power probe, test for ground at the switch's inputs. You see they're there, but the blower doesn't run because of the break in the resistor.
Now that we understand how it's supposed to work, it's time to test it.
I like to use the power probe, but you can use just a test light. And if you look at the connector over here, you've got one connector that has 6 pins and another connector that only has 2.
On the diagram it looks like this. There are 6 separate pins that receive continuity through the switch, and then route it through different combinations of resistors, each one offering a specific resistance to that energy that is trying to push into it. That resistance to that energy is what slows the fan down. Less energy, less speed. And another 2 pins that simply route full energy through the continuity in the fan motor, where it meets ground with no resistance through the blower resistor. No resistance to the energy means full speed. At the connector it looks like this. There are 6 pins that receive the continuity through the switch, and another 2 pins that simply route the full energy through the continuity in the fan motor.
And the 2 go right straight to the blower motor. So that should be your power and ground to the blower motor. With the key on and your blower motor switch in the off position, if you come over here with the test light or your power probe, on these 2 you should have power. The 2 far right ones that go to your blower motor, you should have power. If you look at your wiring diagram, the reason these have power is because with key on, power comes right directly from the fuse box through a fuse, down through one of these wires, through the blower motor and back. It's looking for a ground. So there's power to the motor at all times. It's looking for a ground to tell it how fast to go. Now, there's 3 on the top and 3 on the bottom right. Again, looking at your electrical diagram, this one on the bottom right is pin number 1. If we test that, that has power, but the blower motor is not running. It's not running because it doesn't have ground yet, but it's got power because power is feeding directly through that circuitry into that pin. When we turn the blower motor switch over to high, this should turn to ground and the motor should run. So turn the blower motor switch to high, this wire goes to ground and you can hear the motor running. So that's why we have high. We turn the switch back 1 notch to medium high and you can hear the blower motor quit. Now if we go to this next pin over, which is number 2, that should be the pin for the next speed down. If we put our power probe in there, you can see that we have ground. So the switch is working. The switch is doing its job. It's sending ground to that, but it is not going through the resistor to the motor.
So where exactly is the fault? Well, somewhere in here an open occurred, and as you know, an open means no continuity, and that means whatever comes to it cannot pass through it. So the energy that came to it cannot pass through it.
So the blower resistor is bad. Here's how to change it. Turn your key off. It's very important that there be no power going through this when you disconnect it and take it out of that box, or it'll burn the new one out. So to replace this, just disconnect the connectors. There's 1, 2. There's 2 little bolts that hold this on. And then it just pulls straight out. Now by looking at this, this is a factory original. The replacement is going to look different. It's going to look like this. So when you get one from the box and it doesn't look like that, that's because they've modified it and improved it. To install it, just put it back in there. And you just plug it back in. Now we'll turn the key back on. We'll turn our switch to the low speed. Now it might be a little bit hard to hear on this video, but you can hear the blower actually running now. It's at a low speed. Move it up to a notch. It's blowing stronger. And and then it's blowing full speed. Now you simply close your glove box up and you're done.